Up until this point, we've learned the derivatives of pretty simple functions. So for example, we've learned the derivative of f of x equals x squared is going to be f prime of x, which is 2x. We've also learned things like the derivative of g of x equals 3x squared plus 1 is going to be g prime of x. We use the power rule again. X squared, we bring the 2 down. 2 times 3 is 6. We subtract 1, and we get x to the first power, or just x. And then the 1 disappears because the derivative of any constant is 0. But what we haven't seen yet is how to take the derivative of more complicated functions. So what if we had the function f of g of x? Well, that's what the chain rule is, and that's what we're going to learn today. But let's start by just discovering the chain rule using this example. Well, if I say f of g of x, if I have this composite function, that's the same as putting this one in for the x of that one. And what that means is I'm going to have, instead of x, I'm going to have 3x squared plus 1. So I have 3x squared plus 1, all to the power of 2. That's f of g of x. And if I want the derivative of this, I want d dx of f of g of x, one more parenthesis. If I want the derivative of this, I can just multiply it out. So let's multiply it out up here. We have a simple FOIL here. We have two polynomials multiplied together. The first term times the first term is going to be 3x squared times 3x squared, which is 9x to the fourth. Second term times the second term is going to be 3x squared. 3x squared plus 1 is 3x squared times 1 is 3x squared. Same with the other cross term, and then we get a 1. Now this can be simplified. We can get 9x to the fourth plus 3x squared means we have 2 of them, or I have 3 and 3, which is 6x squareds plus 1. And from here we can just take the derivative. The derivative of 9x to the fourth is going to be, bring the 4 down, we get 4 times 9 is 36. X to the third power, we subtract 1 from the 4. Plus, we have 6x squared, which is going to be 12x. So let's mix things up a little bit, and you'll see why I'm going to mix them up in a second. I can pull a 2 out of this. So let's pull a 2 out. Let's say this is 2 times 36 divided by 2 is 18. X cubed plus 6x. And now let's pull out a 6x as well. I see that I have a 6x in both of those terms. So let's say I have 6x times 2 times, well, 18 divided by 6 is 3. X cubed, take an x away, is x squared. 3x squared plus 6x, take away 6x, is 1. And so what we're left with, and we're going to leave it multiplied out like this for a second. We're going to look at this. If I scroll back up, what we're left with is 3 pieces. And you see why I got those 3 pieces, because I have, let's change the color. I have g prime of x right here. I have g of x right here. And then I have some things that look a little bit like f prime of x. So specifically, what we ended up with is, in that first piece there is we have g prime of x. G prime of x. And it's being multiplied by f prime, because we have the 2 here, we have this 2 here, and we have this 2 here. So this is f prime, but it's not f prime of x, it's f prime of g of x, because inside here is where we have our g of x. And so with a simple example, we see what the chain rule is going to be, and we'll see what the chain rule is going to be in a few examples in a few later videos, but we can see from this example that the chain rule is going to be the derivative with respect to x of f of g of x. When you have nested functions like this, we get the derivative of the inside function multiplied by the derivative of the outside function, with the inside function still inside. And we'll see a lot more examples of this. It'll be a lot simpler when we use the rule directly. But that's the chain rule.